We are going into this topic today. It's called coding and its challenges. Yeah, today I'm going to explain some important aspects on code. You might think like, yeah, coding is simple. That's how people look at it from distance. Coding is not simple, but that's its challenges. Challenges like debugging, challenges like understanding. Although debugging is always most of all the challenges anyway, but coding has a lot of challenges, and coding at times can take you days or even months for you to figure out what's going on. So I want you to watch to the end of the video, and if you have questions you can put it in the comment section. So subscribe also. Don't forget to subscribe. Thank you very much.
Code and its challenges, a deep dive into the world of programming. In a world increasingly driven by technology, code is the invisible force that powers the modern digital landscape. Every mobile app, website, software tool, artificial intelligence system, or embedded device is built on lines of code carefully crafted by developers. While the act of coding may look like a straightforward sequence of typing commands into a screen, the truth is far more intricate. Behind every piece of working software lies hours of thought, testing, reworking, and problem solving. But as powerful and transformative as code is, the process of writing Welcome to David Oluwason TechRise. At DavKids want to make sure to like, share, and subscribe for more entertaining and evolving. Code presents immense challenges, some technical, others intellectual, and many organizational. This comprehensive write-up explores what code is, why it's important, and delves deep into the real-world challenges developers face, with a special focus on debugging, continuous learning, and environment setup. The silent pillars that define a programmer's day-to-day struggles. What is code? In its simplest form, code is a set of instructions written in a programming language to tell a computer what to do. These instructions allow us to control machines and build digital systems ranging from simple calculators to advanced robotics and AI. Coding transforms human logic into machine executable programs. It's the bridge between imagination and automation. Programming languages like Python, Java, C++, JavaScript, Go, and many others are tools through which developers express solutions to real-world problems. Why code matters? The modern world depends on software. Code plays a critical role in web development, creating responsive and interactive websites. Mobile apps, powering everything from banking apps to health trackers. AI and data science, driving automation, recommendations, and intelligent systems. Gaming and graphics, building immersive virtual experiences. Engineering and AI, automating machines, sensors, and smart environments. Without code, modern life would grind to a halt. However, writing code that is correct, efficient, secure, and maintainable is a monumental task. The real challenges of coding. Let us explore the major challenges that programmers encounter, especially the ones that silently shape every project behind the scenes. 1. Debugging, the hidden battle. One of the most painful yet essential parts of programming is debugging, the act of finding and fixing errors, bugs, in code. What makes debugging so tough? Invisible errors. Some bugs don't crash your program, they just give the wrong result. These are the most dangerous because they often go unnoticed. Complex logic chains, errors, can originate far from where the symptoms appear. Intermittent bugs, these only happen occasionally, under certain conditions, making them nearly impossible to track. Third-party issues, sometimes the bug isn't even in your code, but in an external library you depend on. Common debugging tools. Breakpoints and step debuggers allow programmers to pause code and examine each step. Print log statements used to display internal states during execution. Automated testing ensures code behaves as expected with different inputs. Error logs and stack traces provide clues about what went wrong and where. Is more than debugging teaches patience, logic, and persistence. A good coder isn't someone who writes perfect code, it is someone who can fix it when it breaks. 2. The volatility of knowledge in programming. Unlike many other fields, the knowledge you gain in programming can become outdated quickly. This is one of the most underestimated challenges in tech. The ever-changing landscape. New tools every month, frameworks and libraries are updated or replaced rapidly, for example, Angular, React, Next.js. Changing best practices, what was once standard can become bad practice overnight. Deprecation of technologies, APIs, methods, and services are discontinued frequently. Trends and hype cycles, new paradigms, for example, blockchain, serverless, constantly change what's relevant. Implication for programmers. You must keep learning to stay relevant. You can't relax on past knowledge, regular upskilling is required. You need strong fundamentals because tools change, but core principles, algorithms, data structures, logic remain. How to keep up. Read documentation and changelogs regularly. Subscribe to developer communities, Stack Overflow, GitHub, Hacker News, Reddit. Watch tutorials, take online courses, Udemy, Coursera, FreeCodeCamp. Join forums and attend tech meetups or webinars. Build side projects to practice new tools in real scenarios. Programming isn't a destination, it is a journey. A good developer isn't the one who knows everything, but the one who knows how to keep learning. 3. Software installation and environment configuration. Another huge and often overlooked challenge is the setup, getting your software environment ready before you even begin to write code. Common setup nightmares. Package dependency conflicts, one library needs version 1.0, another needs 2.0, resulting in a crash. Operating system incompatibilities, code written on Linux may not work on Windows or MacOS without adjustments. Path and environment variables, one misconfigured setting can stop your entire program from running. Database or API connections, these often require additional configuration, permissions, ports, and authentication tokens. Real-life examples. A data science project using NumPy, Pandas, and Matplotlib may crash because of an outdated Python version. A web application might not run locally unless Node.js, Mongo, Redis, and other services are all installed correctly and running. Tools that help. Package managers, pip, Python, npm yarn, JavaScript, Composer, PHP. Virtual environments, Venv, Conda, NVM, etc. Isolate dependencies. Containerization, Docker, can replicate exact environments across machines. Cloud IDEs, services like Replit or GitHub Codespaces reduce setup time. Is more than, the environment must be right or nothing else works. Setup errors waste valuable time and energy, especially for beginners. Other core challenges in coding. While debugging, knowledge volatility, and setup are massive hurdles, they reign not alone. Coding is a holistic craft, and many other obstacles play a role. Complexity of logic. Writing efficient algorithms and solving real-world problems requires deep thinking. What seems simple may involve recursive thinking, data structure design, or mathematical modeling. Platform compatibility. Code may behave differently on various platforms, browsers, or devices. Developers must constantly test and tweak for consistency. Security and safety. With the rise in cyber threats, developers must ensure their code is secure, protecting user data, preventing hacking, and following encryption standards. Testing and quality assurance. Testing is not just an option, it is essential. But writing comprehensive tests, handling test data, mocking services, and maintaining test coverage takes time and discipline. Collaboration and version control. Teams use tools like Git to manage code together. Merge conflicts, bad commits, and poor communication can lead to serious issues. Final thoughts: coding is a craft, not just a skill. At its core, coding is the art of solving problems through logic and creativity. But behind every software application lies the relentless frustration of debugging, the constant need to unlearn and relearn, the hours spent configuring environments before typing a single line of code. It is these invisible battles that make great developers, not just their ability to code, but their ability to adapt, persist, and evolve. So whether you're a beginner facing your first bug, or a senior developer managing a complex CI/CD pipeline, remember this. Coding is not just typing instructions. It is a lifelong journey of learning, breaking, fixing, and building again.